And welcome again. Here is one more problem that is also related to hydrostatic pressure, and you can see the problem. It says a uniform heavy lever of length L, one end of which is hinged, is in horizontal position right now, resting on the upper end of a rigid rod. I think this rod they are referring, along which it can slide without friction or with friction. I don't know yet, but they are sliding. The other end of the rod is attached to a piston is here, tightly inserted into one of the knees of the vertically fixed U tube with cross-sectional area S. The cross-sectional area of the U tube is this, and this is S. And what next? Into which a liquid of density rho is poured, right? After an added volume V of the same liquid. Initially it was in equilibrium, and then what happened? After an added volume V of the same liquid, okay, that means same density. After an added volume V of the same liquid to the open knee of the tube, that means in this thing, okay, the lever again establishes equilibrium, but this time rotates around the hinge. Hinge you can see here. Hinge rotates around the hinge axis by an angle alpha, while the rod retains a vertical position. That means this rod has to remain vertical all the time. Okay, fine. Neglecting the masses of the piston, rod and friction. Friction is neglected. That's fine. That gives me a relief. Find the mass of the lever M. Lever, that was this, its mass we needed to find. If in the initial position the distance from the upper end of the rod, this end, to the axis hinge, this thing, is h by 4. Okay, so we need to solve this problem, but in initial position, what happens in initial position? Everything is here, as you can see. This rod is massless. This rod is massless. That means the two forces, normal exerted by the lever on this massless rod, and the force exerted by the piston, or piston is also massless, so take this piston and rod together, and on this piston I can see the liquid beneath will exert a pressure force, and on the upper side, on this rod, this lever exerts a normal force, not its weight, normal force. So this is the pressure force and this is the normal force, and they are going to be the same because rod is massless. Okay, so in this initial case, I guess the water level is here, and I assume this height is h, so that this pressure force can be simply written as rho g h, and the area is S in this case. The cross-sectional area of the piston is S given, so I should write it S. So this is the force here, and this force will be equal to normal, and a force of gravity that is at the length L by 2 from it will be acting like this. Its mass is m, and which is to be found, so mg is acting on this, and on this lever, I can say on this lever, two forces are acting. One is the force of gravity and another one is the normal reaction of the rod on this lever, that will be in the direction, in the upward direction. And we can write, we know the forces, so we can write the lever rule. There is a moment, equating moments about this axis, about this hinge. We can equate moments, and that I am going to tell it a lever rule, the lever rule for the initial horizontal position. And I can write it, and this will be nothing but for mg is producing a torque in clockwise direction, and normally is producing a torque in anti-clockwise direction. So I can write the lever rule as mg multiplied by L by 2 is, this must be equal to rho g h s, and this length is L by 4, and this is our equation 1. And let's see in different in another cases, when some water, when some liquid, more liquid of volume V is getting poured in this open knee or whatever, open leg, whatever you want to tell it. And I have another picture ready. And in this condition, this was the initial position that is here in this picture, and this length is h. So this was the initial position. Initially I assumed in this figure that initially the piston was here, and of course rod was here only, and length of the rod is constant. It's a rigid rod. So now I am going to pour some liquid in it, and I poured a liquid, and when I pour some liquid into it, this is also going, the piston is also going to move some length. And you can see here, I assume that the length delta x, the piston has moved up by a length delta x, and so that means this initial thing was moved to here. That means you poured a total length of liquid, total liquid column of length, volume by surface area, volume by cross sectional area, and this length was poured in it. I guess this length was poured in it, and simultaneously it moved from this position to this position. That length is delta x, and so the piston also moved. The piston in the right knee also moved some distance delta x upward, and this is the new position. This is the new level of liquid in the left knee of this U tube, and piston has moved to this position, and I call this length h1. So, and next thing, what happened with the lever, I can explain what happened. If I go right from after adding liquid to the tube in the left knee, the piston together with the rod will move upward. It moved, or I can say the piston together with the rod will move upward, and the lever will turn. We will rotate, in fact, about the hinge, and in this case, the moment arm of force of gravity has changed, because this length is L by 2. This length is L by 2, and moment arm of gravity in this case is this, and here is the right angle triangle, and this angle is alpha. Of course this angle is alpha, and so will be this angle. You know why? Because this alpha is the angle between corresponding perpendiculars. Normal is perpendicular to, since this is frictionless, since there is no friction between the lever and the upper piston part, upper part of the rod, so it will also move, and normal will be always perpendicular to the rod because there is no friction. So this normal is perpendicular to the rod in this case, and this is vertical, so this angle is also going to be alpha. You can see each of the things, but we need first to find the lever arm of this mg, and this is L by 2 cos alpha. Lever arm of the mg is this length, and this is mg L by 2 cos alpha. You can see here. And what about the lever arm of normal reaction on the rod? And initially it was this length, L by 4 length, but now it has moved somewhere, so this has become now the new lever length, this length. And here you can see the triangle, this L by 4. So this is the new lever length, say L dash, and this angle is alpha. So, and this length is L by 4. So in this case, from this triangle, because this angle is right angle, you can say hypotenuse into cos theta equal to base. That means L dash cos alpha will be equal to L by 4. That means L dash will become L by 4 cos alpha. That is the new lever arm of the normal force. And since the rod remains vertical, nothing else, and in this case, for the since this rod is massless, this rigid rod is massless, so the forces acting on it are a component, vertical component of the normal reaction, and the pressure force beneath it here. And the pressure force here is simply rho g h1. You can see this height is h1, so pressure force here is rho g h1 multiplied by s. This is, and this will be equal to not n but n cos alpha, only vertical component of cos alpha, because the rod remains vertical always and it is massless. So if two forces are acting on it, both forces must be, if we consider the Newton's second law of motion for the rod, for the rigid massless rod, light rod, then if two forces are acting, they must be equal and opposite. So I wrote this equation, and I have many things together. And now I am going to write the lever law for, in this situation, in this new equilibrium condition, the lever law. That means the equation for moments. And gravity, moment of gravity in this case will simply become mg, and lever of mg was what? L by 2 cos alpha. L by 2 cos alpha. So I'm going to write down here L by 2 cos alpha is the torque of the weight, and that will be equal to the torque of normal in this case. And the torque of the normal in this case is, normal is equal to what? Normal is equal to rho g h1 s by cos alpha. You can see from here the normal force itself is rho g h1 s by cos alpha, and its lever arm becomes L by 4 cos alpha. So you can equate them both, and it becomes the second equation. the lever equation in the new equilibrium condition, and we need to find one more thing, that is delta x, because delta x, without delta x we are not going to move any further in this problem, solution of this problem. So we need to find out delta x. And I guess if you can see this picture, this length is delta x in this triangle. Oh, sorry. In this triangle, I can draw it here. This length is delta x and this length is L by 4, and this angle is alpha. So I can write a relation between delta x and L by 4. L by 4 is given, 4 is always given, and L is also given, alpha is also given. So we can find a relation between delta x and L by 4, and that delta x will be equal to L by 4 tan alpha, because tan alpha equal to delta x by L by 4. So delta x equals L by 4 tan alpha. This is my equation number 3 for this in equilibrium condition. Now one more thing we need to establish the relation between, that is between h1 and this delta x, because it's also coming. You can see here h1 is this length and this length is v by delta s. So you should write h1 equals v by delta s plus this length, and h1 equals v by s plus this length, and this length is what? This length is h minus delta x and minus delta x from here. That means h minus 2 delta x. So h1 is equal to v delta x, v upon delta s plus h minus 2 delta x. You can see your picture, consult your picture, and you will find everything. And so you can also write is v by s plus h minus 2, put the value of delta x here, that is L by 4 tan alpha, and this is our equation number 4. And use equation number 1, equation number 2 and equation number 4. 3 is not needed now, and you can solve the obtained equations, and you are going to find out the answer, the value of our m. I already found out, so I don't need to find it again. And this m becomes, m I got is rho ls tan alpha minus 2v divided by 4 multiplied by 1 minus cos cube alpha, and this is the answer I got. You can check your answer. Thank you very much for watching.